Now we are on question number 5, case study, question number 5, that's based on carbon's compound. So you may pause the video and read this information given here. I'll straight away start with the question here. So if I take the first question, check for the first one is what? This is the first question. It says, which of the following do not contain a double bond? And these are the options given here. So let's begin with the sulfur dioxide. Sulfur dioxide. Well, check for the sulfur dioxide. Sulfur has 6 electrons in the outermost shell, and oxygen with again 6 electrons in the outermost shell forms a bond like this. Right. So you can see from here, they form a double covalent bond. But then how do you get to know? Check here. Sulfur, as you know, one pair of electron indicate one bond. So there is a 2 pair of electron with sulfur and oxygen and with other atom of oxygen. So it has a double bond. Now I'll see the next one, that is ammonia, that is NH3 here. The nitrogen whose atomic number is how much? Atomic number is what? 5. No, 2, 5 is the configuration, 7. So it has 5 electrons in the outermost shell and hydrogen shares 1 electron. So see there's 3 hydrogens. So these 3 electrons, you can see that they have taken 5 electrons of nitrogen. Now hydrogen will, 3 hydrogen atoms are there. So each will share 1 electron. So as you can see, single covalent bond, single covalent bond, single covalent bond, and this is unshared pair of electron. So we can see that this is forming only a single covalent bond. So the question was that only, right? We have to find the one which do not contain double covalent bond, but there are more than one correct option. So we will be, as of now, decided that we have got one correct answer, and that is ammonia. Look for HCl, hydrochloric acid, chlorine whose atomic number is 7. So electronic configuration is how much? Electronic configuration is 287, atomic number 17. So hydrogen, as you can see, will share 1 pair of electron, and the octet rule is for like of chlorine is satisfied. And here you can see it's a single covalent bond. So therefore, the second option is also correct. Now, let's check for the oxygen. Oxygen molecules forms a double covalent bond, but then you need to understand why. So this oxygen has 6 electrons in the outermost shell. So is for the other oxygen atom has to be. You can see that their oxygen is sharing 2 pair of electrons. So it's a double covalent bond. So correct option is the second and the third. Well, second and third is option B here. Second and third only. Now we will take the other questions here also. If I remove this, I remove this and come up with the next question, that is second part over here. Right, the one we have to identify the one having triple bond. Well, it is nitrogen, but let's understand why nitrogen. This is N2, right? Nitrogen whose atomic number is what? 7. So configuration is 2, 5. It has 5 electrons in the outermost shell and needs 3. So that's the reason one atom of nitrogen will put forward 3 electrons to be shared and rest 2 behind it. And similarly, the other nitrogen atom will follow the same thing. So you can see from this here that this nitrogen now got 8 electrons, so is this nitrogen. But what is important here is you can see there are 3 pair of electrons, so there will be triple covalent bond. So nitrogen with atomic number 7, the nitrogen molecule, right? So since there is only one correct option, we will not be looking for the other parts. A is the correct answer in this case. Now, third one, what is the third question? Third part, not the third question. Next is, it says the shared pair of electrons is said to constitute the shared pair of electrons, constitute dash bond between hydrogen atom. Well, we know that it's a single covalent bond between hydrogen atom. Hydrogen with atomic number 1 has 1 electrons in the outermost shell. Will obtain the helium configuration if it has 2 electrons. So they share one pair of electrons to form hydrogen molecule. So the correct option is A over here. Now we have more. I've taken 5 parts here. Let's check for the fourth part. In the fourth part, it says which of the following molecules has its atom joined together by double covalent bond? Okay, so they are all covalent compound, but thus we have to look for the double covalent bond. Methane is something that every student as of now, I mean, after completing the chapter, they must be knowing, or you must be knowing here, I mean to say, that is, this is methane structure having only single covalent bond. We need double. Water molecule, this is methane. Water molecule is what? H2O. You should know that hydrogen always bonds with a single covalent bond. So you can say water molecules have single covalent bond. So these two are not correct. Next is carbon dioxide. Yes. Carbon with the atomic number 4 shares 2 pair of electrons. I mean to say that this oxygen atom now got 8 electrons. This oxygen atom with 6 electrons will share 2 electrons. And this carbon got how much? 8 electrons. So this is what the structure of carbon dioxide. So we can say that we have only one correct option. So this is correct. But let me also tell you the last option why we are discarding this. Nitrogen, what is it? Nitrogen trichloride. Nitrogen trichloride. So chlorine is like this. Chlorine, you know that it shared 1 electron only. So these two unshared pair of electrons. Nitrogen has how many? Has 5 electrons. So you can see from here that chlorine will share 1 electron and will have its remaining 6 electrons over here. This chlorine atom 1 and remaining 2, 3, 4, 5, 6, 7, 8. And this way. So you can see that it is single covalent bond. This is unshared pair of electrons. So nitrogen will have this structure. Nitrogen molecule is not there. Nitrogen trichloride. Tri is for 3 chlorine. Right. So we got that the correct option here is option D. Now moving to the other questions over here. So what is it? We have done 4 parts. So we'll have one more part here. That is the 5th part. The 5th part is it's with a structure. Right. What is it? Chlorine. Chlorine is a diatomic molecule, right? Cl2 having 2 atoms in one molecules. And we have to choose this structure which is correct. So let's make the correct structure of chlorine instead of going through it. Chlorine with chlorine, as you can see, Cl2 molecule. As you know, chlorine has 7. Configuration of chlorine is what? 287 electronic configuration. 7 electrons in the outermost shell. So definitely it will need 1 more electron. So it will keep this electron over here. This chlorine atom will do the same thing. Now check here. This octet rule is done here. So you can see chlorine share 1 pair of electron. Now among the option, what you can see that the first option, if it is, I know it's very small, this cannot be correct because it is sharing 3 pair of electron, 2 pair of electron, 1 pair of electron, but then you have to count 2, 4, 6, 2, 4, 6. Here is what? 2, 4. Yeah. So again, this is incorrect. So correct will be this only. The reason is, as you can see from the picture here, that only 1 pair of electrons are shared and remaining 7 electron is outside. So that's why it's correct. Now we'll come to case study 6. Now we'll do case study question number 6 based on the chapter carbon's compound. So as you can see, an organic molecule is given here with the structure as this. Now let's see what are the questions related to this. First question, if I type, what was it? So this is the first question. It says, to which homologous series does the following belong? So what you can see that here, each of them is bonded by a single carbon atom, and this is OH, right? OH, and OH is what? Alcohol. So this is alcohol. A very simple question I can see. Now let's type the next one. Let me type the next one. What is it? This is what is the general formula of this homologous series? Yeah, this is very interesting. General formula of this homologous series. So how to determine the general? Mostly we don't learn these general formulas in class 10th. How to decide? So what I suggest, let's start keeping like plugging n as 1 and check whether we are going or not. Like we know that ethanol with one carbon atom is what? CH3OH. So if you replace H with, sorry, N with 1, so what I'm getting? C1H2 into 1 plus 1, right? 2 into 1 is 2 plus 1, 3, and this is OH. All right. So this is by placing N, we are getting this. And similarly, if I place NS2, let's say placing NS2, what I'm getting? 2 into 2, that is 4 plus 1, 5 OH. Yeah, I can see this is the correct answer in this case. Now let's figure out. We have figured out the first option is the correct. I have something else to say on this. So we have figured out this as correct. Now check for this one. What if you are placing N as 1 here? So this become what? Placing N as 1, it is H is how much? 2 into 1 is 2 and O. So that comes out to be wrong here. So similarly, you can figure out other also, which of them. So we got the correct answer as A is the correct answer. And I'm talking about why testing for the others, like say, for example, uh, just to for you to understand how to figure out which is the general formula. So the first is correct over here. Now I'll see the next question from here. The next question is, that is 3. So question number 3 is this. Which of the following is the next member of this? Okay, how many carbon atom you can see? This is 4 carbon atom. So it's C4. I should write here C4. And how many H are there? That's if I talk about these H, right? Because OH I'll write separately. So it's 7, right? No, 9. 9 OH. Back count 4, 8, 9. Yeah. So in the next homologous, as you know that the next homologous series is obtained by adding CS2, or I can say that each member differ from its succeeding and preceding member by CS2 group. So if I add one carbon and two hydrogen, I'll get what? Carbon from 4 to 5. Hydrogen is 9, 9 plus 2 is 11. I repeat, by adding one carbon and two hydrogen, I get this C5H11OH. C5H11OH. So C is the correct in this case. Now check for the third. This is the third part. Now I'll come to the fourth part here. What is it? Fourth part. Fourth part is this. Which of the following is the third member of this homologous series? Third member will be what? Will have how many? 3 carbon atom in a straight chain. And as you can see, these hydrogens are bonded with single covalent bond. And the functional group OH. You may join in any other way. So you can figure out there are 3 carbon atom bonded with 6, 7 hydrogen, and OH we write by convention. OH should be written at the end. Well, we got this. Huh? A is the correct option in this case. Now, fourth, when we are left with one more, I suppose fifth, taken 5 only. The fifth question is, which is the second member of this series? First member in case of alcohol, right? Not in every functional group. In alcohols, begin with one carbon atom and one denotes meth, right? And methane is this. From here, if you remove this E and add OL, that becomes the first member, that is methanol. But we are looking for the second member, so it has to be ethanol. But remember, not every homologous series starts with first one carbon atom. Like as in case of, had it been ketone, then the first member, let's say I'm talking about the first member, will not start with one carbon atom, right? It has 3 carbon atom as the first member in the first member. So its name will be the first member. Once again, I'll tell you, talking about the first member of ketone homologous series will not start with 1, 2 carbon, starts with 3. And in that case, it is propanone, right? Now we'll come to the next case study 7 now.